Hey everyone, welcome back to the College Algebra playlist. In previous videos, we took a look at several different types of equations. Alright, so in this video, I want to take everything we've learned about solving equations and apply it to some concrete examples. Alright, so let's get started. Okay, here we go. Example 63. Here we're asked to solve for x where x does not equal -4. Okay, so this is a rational equation, which means we'll need to be careful when we get a solution, right? We'll need to check it to make sure it's not extraneous. All right, and we'll just check it against this list here, right? X cannot equal -4 because if you plug a -4 in, you get division by 0. All right, so let's take this equation and rewrite it like this. All right, so we have all fractions here, and now we just need to figure out what the LCD is. All right, that's what we're going to multiply both sides by to clear these fractions. All right. The LCD is x plus 4, okay? So we're going to multiply both sides by that, right? On the right-hand side, we'll just have some multiplication happening, and then on the left-hand side, we'll have some distribution happening, right? We'll use the distributive property to get rid of the parentheses, okay? So this is what it looks like when we distribute on the left-hand side, right? X plus 4 times 2 over 1, and then we have x plus 4 times a minus 3 over x plus 4. All right, and on the right hand side, right, we still just have this fraction multiplication happening. All right, so we can see that the x plus 4s are going to cancel over here, and they cancel over here as well. All right, so that leaves us with the equation x plus 4 times 2 minus 3 equals x plus 2. Okay, so we got rid of the fractions successfully. All right, let's take this result to the top of the screen. This is what we have. And right here, I'm going to distribute this 2 to this x plus 4, right, to get 2x plus 8. All right? And then we have minus 3 equals x plus 2. Okay? So I got rid of the parentheses in accordance with PEMDAS, right? That's what I should do first. And so next, we need to make this subtraction happen. All right? So we have 2x plus 5 equals x plus 2. All right? And now we want to get everything involving x on the left-hand side and everything with constants to the right-hand side. Okay? So let's subtract x from both sides, and that'll give us x plus 5 equals 2. All right? And then let's subtract both sides by 5, and that'll give us x equals -3. Okay? So the solution is x equals -3. And a quick check here, does that equal -4? No. Right? This value is allowed. Okay? This restriction, right? We can't have -4 because then we have extraneous solutions, right? We have division by 0. But our solution is fine, right? It's -3. Okay? So let's move on to the next example. Here we're asked to solve for w. All right? This is an absolute value equation. All right? Remember, the first thing we need to do with absolute value equations is isolate the absolute value. All right, so let's add 7 to both sides. And that gives us the absolute value of 2w minus 1 equals 5. All right, so if the absolute value is 5, that means that this stuff inside, right, this blue stuff, we can either set it equal to positive 5 or -5, right? In both of those situations, right, we're a distance of 5 units away from 0. Okay, the absolute value is 5. All right? So the distance is 5 over here as well. All right? Let's get rid of this number line because we don't need it anymore. All right? And let's divide our work like this. All right? Let's solve each equation one at a time. Okay? Here on the left, we're going to add 1 to both sides. And that'll give us 2w equals -4. And then let's divide both sides by 2. All right? The 2's cancel on the left-hand side, and that gives us w equals -2. Okay, so that's one solution. And then here on the right, let's add 1 to both sides. All right, and that'll give us 2w equals 6. And then we'll divide both sides by 2. Okay, and the 2's cancel on the left-hand side, and that leaves us with w equals 3. All right, so the solutions are -2 and 3. Here we're asked to solve for y. all right, we have a cubic equation. All right. So on this playlist, we solve polynomial equations like this by factoring. Okay, we're going to try to factor the left-hand side. All right. And how do we do that? We do that by pulling out the GCF. All right. In this case, the GCF is just y. Okay. So y times something plus something will give us 4y cubed minus 9y. All right. Let's figure out what we need to put in these blanks. Okay. Y times what equals 4y cubed? The answer is 4y squared. Okay? And then over here in red, the question is y times what equals negative 9y? And the answer is negative 9. Okay? So we successfully pulled out the y, and we're left with this thing here. All right? Which we can simplify to 4y squared minus 9. All right? So we've successfully factored the left-hand side, but we can actually factor it even further because this business in the parentheses here, this is the difference of squares, okay? So we can factor that as 2y plus 3 times 2y minus 3. And then we just have this y hanging around, right? We'll tag it on to the left here, all right? So I have three things being multiplied together, and they equal 0. Okay, so that means I can set each piece equal to 0, all right, and then solve. Okay, over here I have y equals 0, right? We don't need to do any algebra there. We just get the answer right away. Okay, y equals 0. All right, this equation in the middle, let's subtract 3 from both sides and then divide both sides by 2 to get y equals negative 3 halves. Okay, that's our second solution. And then over here, let's add 3 to both sides and we get 2y equals 3. And then we'll divide both sides by 2 to get y equals 3 halves. Okay? That's our third solution. Let's move on to the next example. Here we're asked to solve for x, and we have 4 times something squared minus 9 times that same something equals negative 2. All right? The first thing I want to do is bring this 2 over to the other side. All right? We're going to have some sort of quadratic equation here, right? So we want to have this thing set equal to 0, okay? So if we wanted to, right, we could FOIL this and distribute this and then gather every like term together to get a quadratic equation set equal to 0, right? We could do that, or we could recognize that this equation is in quadratic form, all right? So we can perform a fancy substitution to make this easier, all right? The question is this exponent 2 double this exponent here, the invisible 1? All right, there's an invisible 1 exponent here on x minus 1. All right, the question is 2 equal to 2 times 1? And of course the answer is yes. All right, so this is an equation in quadratic form. All right, so let's perform the substitution u equals x minus 1. All right, let's replace x minus 1 with u, all right, in blue. Okay, so we have 4u squared minus 9u plus 2 equals 0. All right, let's get rid of the unnecessary parentheses. All right, and now we have a trinomial in u, right, with a leading coefficient other than 1. Okay, so remember my advice for solving quadratic equations. If this leading coefficient is something other than 1, then use the quadratic formula. All right, so this is what we have. And this is what it looks like when we plug in the values for A, B, and C, right? A is in red, B is in green, and C is in purple. Okay, so here are my values. All right, and we can simplify this. All right, we're going to get 9 plus or minus the square root of 81 minus 32, whole thing over 8. All right, let's take this result to the top of the screen. Okay, here's what we have for u. And I'm writing down this substitution here, right, because we're going to need it in a second. All right, we'll come back to this later. For now, let's just keep working in black. Okay, so u equals this thing, which equals this, right? 9 plus or minus the square root of 49. And that's a perfect square. All right, so our answers are going to be rational numbers. All right, we get 9 plus or minus 7 over 8. All right, and that gives us two solutions, right? We get 9 plus 7 over 8, that's 16 over 8. And then we get 9 minus 7 over 8, right? That's 2 over 8. Okay? So u equals 2 and 1/4. All right? Those are the two solutions for u that we get. All right? Let's divide up our work when we go back to retrieve our solutions x. Remember, the original equation is an equation in x. All right? So we have our answers for u. Now we just need to get our answers in x. All right? So we're going to replace this u here in blue with x minus 1. All right? So we have x minus 1 equals 2. If we add 1 to both sides, we get x equals 3. All right? So that's one solution. And then over here, u equals 1/4. Right, we can replace the u once again with x minus 1. Right, so we get x minus 1 equals 1/4. And when we add 1 to both sides, we get x equals 1 plus 1/4, which is 5/4. All right? So these are my two solutions to the original equation, which was an equation in x. All right? Let's move on to the next example. All right, example 67. Here we go. Here we're asked to solve for w. All right, we have w minus 1, whole thing to the 3/4 power equals 8. All right, the first thing we're going to do is get rid of this rational exponent. Okay, we're going to raise both sides to the 4/3 power. All right, and when we do that, on the left-hand side, right, this is a power on top of a power, right? So we multiply the powers, and 3/4 times 4/3 is equal to 1, right? Those are reciprocals of each other, so the product is just 1. Right, so that leaves us with w minus 1 to the 1 power, right, which is just w minus 1. Okay? And on the right-hand side, we have some cleaning up to do, right? This is 8 to the 4/3 power, right? We can simplify that. All right? We take the denominator of this rational exponent, and we put it in here in the index for the radical, right? And then we raise the whole thing to the numerator, which is 4. All right? We know what the cube root of 8 is, in parentheses, right? The cube root of 8 is equal to 2. Okay? So in parentheses, we have 2, right? And we're raising that to the 4th power. All right? 2 to the 4th power is 4 times 4, which is 16. All right? So now we're ready to isolate w and get an answer for this. All right, let's add 1 to both sides, and we get w equals 17. Okay? Great. So that's our solution. Let's look at one more example. All right? Here we're asked to solve for x, and we have this business here, right? This is a radical equation. All right? Remember, we need to check our solutions for rational and radical equations because of the possibility of extraneous solutions. All right? So the first thing we should do is isolate the radical. All right? Let's add 2 to both sides, and we get this. All right? And then we need to get rid of this square root, right? We're trying to isolate x, so we need to get rid of this radical. All right? We can do that by squaring both sides. All right? So the square root of something squared, right, is just the something inside, right? The square root and the power 2 undo each other. So on the left-hand side, we have 3x minus 1, and on the right-hand side, we have 2 squared, which is 4. Okay? Let's add 1 to both sides, and we get 3x equals 5. Okay? And then let's divide both sides by 3. That gives us x equals 5/3. All right? So before we put a box around this and declare it to be our solution, remember, we need to check this. We need to check this solution in the original equation. All right? So let's try it out. Let's plug in 5/3 for x here. All right? That gives us this. All right? So we want to know if this is a true equation, right? Does it give us something valid? The 3's cancel under the radical here, right? So we have the square root of 5 minus 1 minus 2, and we want to know if that's equal to 0. All right? The square root of 5 minus 1 is the square root of 4, and the square root of 4 is just 2. Okay? So we get 2 minus 2 on the left-hand side, right? And 2 minus 2 is 0. So 0 does equal 0, which means that this solution here is valid. All right, x equals 5/3 is our valid solution to the radical equation. All right, that does it for this video. Thank you for watching, and like and subscribe.